We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system.
We're looking at Neptune's orbit, and it's not following Newton's laws. And this is odd.
The closest images ever taken of Neptune revealed shocking discovery. For ages, Neptune has captivated scientists and dreamers with its mysterious charm, hidden behind a veil of secrecy and passion. But because of tireless efforts in scientific discovery, scientists are on the verge of a remarkable breakthrough, the clearest pictures ever taken of this faraway, icy giant. These images provide a peek into Neptune's stormy atmosphere, revealing a surprising finding that will change how people see the outer edges of the solar system forever. In August of 1977, Voyager 2 embarked on an extraordinary journey through our solar system, venturing where no spacecraft had gone before. It set out to explore the outer reaches of the celestial neighborhood, marking a remarkable moment in space exploration. After a 12-year journey, Voyager 2 reached Neptune in 1989. As it approached the distant ice giant, it captured breathtaking footage that unveiled a majestic world shrouded in stirring bands of azure clouds. Imagine witnessing this distant sibling of Jupiter, adorned in shades of mesmerizing blue. Among Neptune's mysterious features, Voyager 2 detected a colossal storm raging across its atmosphere, resembling a massive slate-colored uproar. Additionally, the spacecraft discovered 4 mysterious rings encircling the planet, along with 6 previously unknown moons, adding to the allure of this distant realm. Despite its epic voyage spanning 7.1 billion kilometers, Voyager 2's encounter with Neptune was fleeting, lasting only a few fleeting hours. However, this brief rendezvous provided humanity with unprecedented views of the distant ice giant, capturing the essence of Neptune's captivating beauty. When considering Neptune, many of us consider the iconic image memorialized by Voyager 2, a portrait showcasing the planet's towering white clouds and turbulent storms, all bathed in a famous yet mistaken hue of blue. In reality, Neptune's true color is a softer, lighter shade of greenish blue, a subtle detail often overlooked in the grandeur of space exploration. When venturing online in search of more snapshots of Neptune, people quickly notice a scarcity of images. Despite Voyager 2's impressive feat of flying within a hair's breadth of just 4,950 kilometers from Neptune's surface, the number of available photos remains surprisingly low. What makes Neptune so elusive to capture on camera? Imagine Neptune resides a staggering 30 times farther from the Sun than people do on Earth. This vast distance means that it receives only a fraction of the sunlight that our planet enjoys. Consequently, when Voyager 2 finally caught up with Neptune after its gravity-assisted journey past other outer planets, it was hurtling through space at an astonishing speed of 27 kilometers per second. While Neptune may seem like a distant speck in the universe, its allure lies in its perplexing blue hue and mysterious atmosphere. But capturing these mesmerizing details proved to be quite the challenge for Voyager 2. With Neptune receiving only a mere 0.1% of the sunlight that reaches Earth, the spacecraft struggled to snap clear, non-blurry photos amidst the dimly lit expanse. Voyager 2's ingenuity knew no bounds. By deftly working its thrusters to swing as it soared past and employing extended exposure techniques, the spacecraft managed to capture and transmit back to Earth some of the closest and most mesmerizing images ever taken of Neptune. Just a couple of hours before Voyager 2 zoomed past Neptune, it captured an incredibly detailed picture. In it, scientists got a close-up view of some interesting features high up in the planet's atmosphere. Long, wispy clouds that resemble the cirrus clouds people see on Earth. They're not made of water vapor like Earth's clouds. These clouds are crafted from frozen methane, giving them a surreal appearance. Imagine these cloud formations, stretching for thousands of kilometers, run parallel to Neptune's equator. They're not just some puny clouds either. Each streak measures between 50 to 200 kilometers wide. These clouds are so high up that they cast shadows onto the hazy layer about 50 kilometers below. What's even more mind-blowing is that even though Voyager 2 had already checked out all the other gas giants before Neptune, it wasn't until Neptune that people got our first ever glimpse of these elusive cloud shadows, as evidenced by the grainy image captured. These high-altitude clouds are like fleeting guests in Neptune's atmosphere, always on the move and changing shape. Recent observations from the Hubble Space Telescope revealed that these clouds can form and disappear in the blink of an eye, showcasing the dynamic nature of Neptune's weather patterns. When this picture was captured, strong winds would have been swirling around the ice giant, some blowing as fast as 2,100 kilometers per hour. That's 3 times quicker than winds on Jupiter and almost 9 times speedier than those on Earth. Voyager 2 revealed that Neptune experiences some of the most extreme weather in the solar system, and when the spacecraft flew by, it encountered a striking example of this event. This image is the closest view ever captured of the once furious storm known as the Great Dark Spot, a large, oval-shaped cyclone resembling Jupiter's Great Red Spot. This immense weather system was roughly the size of the entire Earth. What's fascinating about this image is that the center of the storm appears to be relatively clear of clouds, forming a vast dark void slicing through Neptune's atmosphere. Neptune is an incredible ice giant about 4 times wider than Earth. Its radius is around 15,300 miles, and it has an enormous volume of 15 trillion cubic miles. To put that in perspective, Neptune is 58 times larger in volume than Earth. This fascinating planet is mostly made of water, methane, and ammonia. Unlike Earth, Neptune doesn't have a solid surface. Instead, its thick atmosphere extends deep into the planet, reaching down to a mantle made of methane and ammonia ice, surrounding a rocky core. Interestingly, scientists think that Neptune might even have a superhot ocean hidden deep inside. Despite its icy name and outer appearance, the conditions inside Neptune are anything but cold. But how can a planet sustain such an ocean when it is so far from the Sun? Sunlight takes a whopping 4 hours to reach Neptune's massive surface. Neptune is incredibly cold, with an average atmospheric temperature of -360 degrees Fahrenheit, making it one of the chilliest places in the solar system. Interestingly, most of Neptune cooled down between 2003 and 2018, though there was some warming near the South Pole from 2018 to 2020, likely due to seasonal changes in the atmosphere's chemistry. The mystery of how an ocean might form inside this icy giant remains unsolved. However, scientists have some theories. One idea is that internal heating caused by gravitational compression or interactions between Neptune and its largest moon, Triton, might play a role. Yet, not all researchers agree. For instance, scientists Sloan Viktorovich and Andrew Ingersoll argue that the chances of oceans forming on Neptune due to its internal heat are quite slim, estimating it at only 15% right now. Their calculations suggest that it might take 1 billion years for the probability of such an ocean to rise to 40%, assuming the giant continues to cool down over time. One interesting theory for Neptune's immense internal energy is that it might have collided with a cosmic object long ago. Neptune stands out as the only planet that radiates nearly 3 times more energy than it absorbs from the Sun. This unusual energy output might be linked to the planet's significant 28-degree tilt on its axis, which is quite similar to Earth's tilt. This tilt means Neptune experiences seasons much like Earth does but with a twist. Each season on Neptune lasts around 40 years. To put it in perspective, one Neptune year equals 165 Earth years, but a day on Neptune is just 16 hours long. This fast rotation generates extremely strong winds. Neptune's atmosphere is composed mostly of hydrogen, making up 80%, with helium accounting for 19% and a small fraction, about 1%, of other gases, including methane. The striking blue color of Neptune is a result of methane clouds in the upper atmosphere, which absorb red light and reflect blue. Methane plays a significant role in shaping the atmospheres of both Neptune and Uranus. Despite being the farthest planets from the Sun in our solar system, these ice giants still receive a significant amount of solar radiation, albeit much less intense than what inner planets like Earth receive. Neptune's vivid blue coloration has captivated astronomers for centuries, but the exact mechanisms behind its striking color continue to interest scientists. One fascinating aspect is the presence of high-altitude clouds, composed primarily of methane ice crystals. These clouds scatter sunlight in a way that enhances the blue coloration, similar to how Earth's atmosphere scatters sunlight to create blue skies. Furthermore, Neptune's dynamic atmosphere exhibits a multitude of features, including massive storms and powerful winds. On the other hand, Uranus presents a different aesthetic, with its muted, pale blue color. This planet's unique tilt, where its axis is nearly parallel to its orbital plane, results in extreme seasonal variations. During its long polar winters, Uranus experiences prolonged periods of darkness, hindering the formation of high-altitude methane clouds that contribute to its overall coloration. In addition to methane, both planets' atmospheres contain trace amounts of other gases, including hydrogen, helium, and ammonia. These gases, along with the intricate interplay of temperature, pressure, and atmospheric dynamics, create a complex and dynamic environment worthy of scientific exploration. Neptune holds many mysteries within its icy depths. Its intense blue coloration, derived from methane in its atmosphere, adds to its allure. But beyond its captivating hue lies a world of extremes. The storms that rage across Neptune's surface are not just any storms. They are colossal tempests, some spanning thousands of kilometers. These atmospheric disturbances, marked by dark and white patches, are the result of Neptune's rapid rotation, completing a day in just under 16 hours. This rapid spin generates intense wind currents, making Neptune the windiest planet in our solar system. The infamous Big Dark Spot, discovered by the Voyager 2 spacecraft, was a monumental find. This swirling vortex, resembling a gigantic cyclone, churned at breakneck speeds, faster than any storm on Earth. Its disappearance, observed by the Hubble Space Telescope, revealed the transient nature of Neptune's weather systems. Moreover, Neptune's magnetosphere, a region of space influenced by its magnetic field, is strikingly tilted compared to the planet's rotational axis. This unusual alignment creates complex interactions with the solar wind, resulting in auroras that dance across the planet's atmosphere. In 2018, Hubble captured the formation of a new storm on Neptune, reminiscent of a similar event detected nearly 3 decades earlier in 1989. These swirling storms, lurking deep within the planet's atmosphere, remain mysterious to researchers despite years of study. What makes these storms particularly captivating is their gradual evolution over time. Unlike the fleeting storms people witness on Earth, these atmospheric giants take years to develop, suggesting a complex and long-term process at work beneath Neptune's turbulent skies. But the plot thickens as the new 2018 storm embarks on an unexpected journey. Initially drifting southward, it seemed destined to fade away into obscurity. Yet much to the surprise of scientists, it abruptly reversed course and began its northward trek, defying conventional expectations of planetary weather patterns. Adding to the interest, a smaller vortex appeared to break away from the main storm. NASA researchers believe that this miniature whirlwind may play a pivotal role in the fragmentation of the larger storm, a phenomenon never witnessed before in Neptune's atmosphere. What's more, the presence of bright methane clouds, known as scooter clouds, within these storms adds another layer of complexity. These swiftly moving clouds, propelled by forces still not fully understood, hint at intricate atmospheric dynamics occurring deep within Neptune's gaseous envelope. Neptune, like its gas giant counterparts, boasts a fascinating feature: a system of rings. These rings were captured in stunning detail by the James Webb Space Telescope in 2022, revealing a spectacle unseen for over 3 decades since Voyager 2's last snapshot. The image unveiled not just Neptune's rings, but also its accompanying satellites, painting a portrait of icy grandeur in the vastness of space. Within this cosmic jewelry box, 5 distinct rings orbit Neptune, each bearing the name of a prominent astronomer whose contributions shaped our understanding of the distant planet. The closest and most diffuse ring, known as Halley, spans a staggering 26,000 miles, with a radial width of 1,240 miles. Composed predominantly of dust particles, it shimmers faintly, embodying the ethereal beauty of the celestial realm. Next in line is Leveria, radiating a brighter glow but marred by a slight inconsistency in its measurements, spanning a width of just over 62 miles. The Lassell ring, however, steals the show with its expansive width of 2,485 miles, dwarfing its counterparts. Despite its grandeur, its dust content is relatively scant, hovering between 20 to 40%, lending it a pristine allure. Arago, the 4th ring, is a challenge to spot, tucked away on the fringes of the Lassell ring. Its diminutive radius of 35,540 miles renders it nearly imperceptible. Lastly, Adams, the narrowest of the rings, orbits at a distance of approximately 39,724 miles, boasting a mere width of 35 kilometers. What truly makes this ring system fascinating are its arcs. These arcs are mysterious, bright bands of dust circling the edge of the ring, creating a mesmerizing display. Each of these arcs has been given a unique name: freedom, brotherhood, courage, and equality. These names reflect the interesting nature of their existence. Interestingly, these arcs are not static, they are dynamic. Brotherhood and equality, in particular, are constantly exchanging material and changing in size, making them even more captivating to scientists. The reason behind the formation of these arcs remains a mystery. However, researcher M.T. DePeter suggests that they might have formed due to the collapse of a parent companion or another object within the Roche limit, which is the distance within which a celestial body, due to tidal forces, will disintegrate due to a second body's gravitational forces exceeding its own. Adding to the intrigue of Neptune's ring system, the James Webb Space Telescope also captured images of 7 out of Neptune's 14 moons. Neptune's moons are categorized into regular and irregular groups. The Webb telescope managed to photograph 6 of the regular inner moons. Some of these moons, like Despina and Galatea, play crucial roles in maintaining Neptune's rings by acting as shepherds, guiding and shaping the dust around them. Despina and Galatea in particular have fascinating orbits that influence the structure of the rings. Their gravitational forces help to contain the ring particles, preventing them from spreading out and maintaining the sharp edges of the rings. These moons' shepherding role is crucial in sustaining the narrow, well-defined appearance of Neptune's rings. In addition to Despina and Galatea, the Webb telescope also observed Triton, Neptune's largest moon, which is unique because it orbits the planet in a direction opposite to Neptune's rotation. Triton is believed to be a captured Kuiper Belt object, making it an object of immense scientific interest. It has geysers that spew nitrogen gas, creating a thin atmosphere and suggesting active geological processes. One of the most captivating elements in Webb's picture is the appearance of Triton, a distant, bright satellite. Triton shines like a star in the image because it emits much more light than its host planet Neptune. This luminosity is due to Triton being almost entirely cloaked in nitrogen ice, which reflects around 70% of the sunlight it receives. Triton holds the title of Neptune's largest moon, outstripping even Pluto in size. Its diameter spans a whopping 1,680 miles, accounting for a staggering 99.7% of all the mass possessed by Neptune's moons combined. What sets Triton apart further is its frigid demeanor. It ranks as the chilliest geologically active entity across the solar system, with surface temperatures plunging to a bone-chilling negative 391 degrees Fahrenheit. This icy terrain, acting as a mirror to sunlight, contributes to its glacial conditions. Similar to other moons around ice giants, Triton experiences tidal locking, which means only one face perpetually faces its host planet. In essence, Triton emerges as a celestial marvel, not just for its size and icy allure, but also for its geological activity and cosmic chill, making it an enigmatic world worthy of exploration and admiration. Triton is quite the maverick in our solar system. Unlike most satellites, it marches to the beat of its drum with a retrograde orbit. That means it travels in the opposite direction compared to its parent planet Neptune. Imagine while other moons obediently circle their planets in one direction, Triton rebels and takes the scenic route. But why does Triton defy the norm? It's believed Triton wasn't originally from around here. Scientists think it hails from the Kuiper Belt, a distant region filled with icy remnants from the early days of our solar system. At some point, Neptune, being the cosmic magnet it is, snagged Triton into its gravitational embrace. As Triton hitched a ride with Neptune, it hit the brakes, slowing down to avoid a head-on collision. This unconventional dance led Triton to settle into its peculiar orbit, where its poles and equator take turns facing the sun. Imagine a cosmic game of hide-and-seek with sunlight, but Triton's rebellious spirit comes with consequences. Its journey could spell trouble for Neptune's other satellites, as Triton's trajectory might lead to cosmic collisions. Unlike Jupiter, with its bustling entourage of moons, Neptune has just a handful of companions. Triton's arrival shook things up, highlighting the stark contrast between the two gas giants. Around Neptune, there's an eerie dance of moons, but Triton stands out among them. It's not just any moon, it's a captured wanderer from the Kuiper Belt, a vast region beyond Neptune populated with icy objects. Imagine Triton as a cosmic nomad, lured into Neptune's orbit by its immense gravitational pull. When Voyager 2 swung by in 1989, it captured snapshots of Triton's surface, revealing a landscape like no other. The images unveiled a patchwork of frozen plains, towering cliffs, and mysterious dark streaks. But what caught scientists' attention were the towering plumes erupting from its surface, hinting at unseen forces at play. Analyzing the craters dotting Triton's terrain, scientists uncovered clues about its tumultuous past. Some craters appeared remarkably fresh, suggesting recent impacts, while others showed signs of erosion, hinting at a dynamic surface reshaped by icy geysers and cryovolcanism. But the most tantalizing discovery was yet to come. Beneath Triton's icy facade, scientists suspect a hidden ocean, possibly kept liquid by tidal heating generated by Neptune's gravitational tugs and the eccentric orbit of Triton itself. If true, this subsurface ocean could harbor alien life, making Triton a prime target for future exploration. And then there are the plumes, towering jets of icy material spewing into space. These geysers not only hint at Triton's active geology, but also suggest a subsurface reservoir of volatile compounds waiting to burst forth. Despite its frigid temperatures, Triton is a world of intriguing complexities. Deep beneath its icy surface, there exists a hidden reservoir of ammonia, a compound often associated with cleaning products on Earth, but vital for the peculiar dynamics of Triton's subsurface ocean. This ammonia acts as a sort of anti-freeze, slowing down the freezing process of water and potentially creating conditions hospitable for life, albeit in a realm vastly different from our own. The interplay of sunlight on Triton's surface further complicates its icy facade. When the distant rays of the sun penetrate its thin atmosphere, they trigger a delicate dance of molecular compression. Nitrogen, the dominant component of Triton's atmosphere, undergoes a curious transformation, becoming pressurized beneath the icy crust. Eventually, this built-up pressure is released in magnificent plumes that erupt into the vacuum of space, a spectacle unseen on any other moon in our solar system. Despite these captivating phenomena, deciphering Triton's true nature remains a tantalizing challenge. Its potential as an oceanic world, harboring hidden seas beneath its icy shell, sparks the imaginations of scientists and space enthusiasts alike. However, confirming this hypothesis requires further exploration and observation, tasks made all the more daunting by Triton's remote location and the technical challenges of space exploration. Moreover, Triton's thin nitrogen atmosphere, a product of solar heating, adds another layer to its mysterious character. This fragile veil of gas hints at the intricate interplay between Triton's surface and the distant sun, shaping its atmospheric dynamics in ways yet to be fully understood. Exploring the mysteries of Triton's origins unveils a captivating narrative of cosmic migration and gravitational ballet. Triton stands out not only for its size, but also for its peculiar backward orbit, contrary to the forward motion typical of moons in our solar system. This unusual trajectory hints at Triton's tumultuous past as a wanderer from the frigid realms of the Kuiper Belt. Within the Kuiper Belt's icy expanse lies a treasure collection of celestial wonders. Among them are not only dwarf planets like Pluto, but also enigmatic objects known as trans-Neptunian objects. These icy bodies, ranging from a few kilometers to hundreds of kilometers in diameter, hold clues to the solar system's early formation and evolution. One of the most remarkable features of the Kuiper Belt is its resonance with Neptune. Resonance occurs when the gravitational interactions between Neptune and objects in the belt cause them to orbit in a synchronized dance. Pluto, for instance, completes 2 orbits around the Sun for every 3 orbits Neptune makes. This harmonious relationship suggests a delicate balance of gravitational forces that has persisted over billions of years. Furthermore, the Kuiper Belt's composition provides insight into the primordial conditions of the solar system. Rich in volatile compounds like methane, ammonia, and water ice, these icy bodies are relics of the solar system's infancy, preserving a frozen record of its ancient past. Piecing together these celestial puzzles, scientists speculate about Neptune's journey through the universe. The concept of planetary migration proposes that Neptune, along with its distant siblings, Uranus, and the gas giants Jupiter and Saturn, may have undergone significant movements during the solar system's formative years. Such migrations could have been triggered by gravitational interactions with other planets or passing stars, reshaping the architecture of our cosmic neighborhood over vast periods. As the ice giant made its migratory journey, it played a crucial role in retaining numerous celestial objects within the Kuiper Belt. Without this migration, the gravitational forces at play could have flung many of these objects out of the solar system, potentially altering the dynamics of our cosmic neighborhood. Interestingly, this migration might have also influenced the orbits of other planets, including Neptune itself, hinting at the intricate dance of celestial bodies in our solar system. Neptune continues to bewilder astronomers with its mysteries. Beneath its serene surface lies a world shrouded in secrecy, with questions lingering about its inner composition and the mechanisms behind the formation of ice giants like it. Scientists are eager to delve deeper into Neptune's depths to unlock the secrets hidden within its icy core, hoping to uncover clues about the origins and evolution of these distant worlds. Future scientific expeditions hold the promise of unraveling the intricate chemistry and dynamics of ice giants, shedding light on their role in the grand variety of the universe. These missions will not only deepen our understanding of Neptune, but also provide invaluable insights into the broader processes shaping planetary systems both within and beyond our own. With each discovery, people edge closer to unraveling the cosmic mysteries that have captivated humanity for generations, arousing curiosity and expanding the boundaries of human knowledge. What are your thoughts about this shocking discovery of the closest images ever taken of Neptune? Share your thoughts with us in the comments section below. Thanks for watching another episode of Voyager. While you are still here, make sure to click the video on your screen for more quality content.